Hi, hello, namaskara. Myself Mahesh Prasad from Department of Physics. As you know, well, dear students, right now we are in a chapter that is motion in a plane, right? So we have discussed many concepts under this particular concept, like vector. Under vector, we have seen different types of vector, and also we have discussed about concept of projectile motion. Under projectile motion, we have discussed three major phenomena like horizontal component as well as vertical component, and the maximum horizontal height, the maximum height, and as well as we have discussed about the time of flight, as well as we have discussed the maximum range that projectile motion can have, and we have discussed like if we threw any object with the angle of 45 degree, it can reach maximum range, right? So these are the basic concepts we have discussed so far, right? So now it is a time to see kind of circular motion. What comes to your mind? Circular motion, when we can have a uniform circular motion of any body. So if they are somewhat like this, so we can have that if any body is rotates with the constant velocity or constant speed, we can have that particular body is in a uniform circular motion, somewhat like this. I have one bob over here, one metallic bob, and I'll give some rotations somewhat like this. So when it is when we see this kind of experiment, so which are the phenomena comes into your mind over here? What are the concept of physics which can explain over here? The one, since a body is in a motion, in a circular motion, somewhat like this, don't you think this particular motion, which is also having some velocity over here, but this velocity, it could move in a constant or variable velocity, it depends, right? And also we can have, there could be some angular displacement is also comes into a picture. So that's why we'll go step by step. So initially we'll discuss what exactly the angular displacement. Obviously you know linear displacement, but linear displacement in the sense the displacement with respect to initial position, right? Or change in position of the object with respect to initial position. So if it is a straight, we can call it as a linear displacement. If the body, if it is there in angular or circular motion, we can have angular displacement, right? So now, how to define your angular displacement over here? How to define this? So if you have kind of a circular motion somewhat like this, circular motion somewhat like this. Let us take O as midpoint of the circle over here. Okay. So obviously it is a circle. It should have some radius over here. So let us take R as a radius over here. Okay. So now for a time being, the body which was covered, body which was there at P and which was covered at a distance of Q. And if I join this, we can have one R over here. And the similar concept we have discussed in units and dimension chapter as well. Then we have discussed angular displacement, right? So now, whenever we are rotating in the direction of angle somewhat like this, that is called as the d theta. Okay. So now, d theta is the change in displacement. So this change in displacement with respect to what? Angular displacement. So now, can I have a d theta, and this looks like the basic formula, that is nothing but arc length with respect to radius of the circular motion over here. So here we can have arc divided by radius. What is the arc we have? That is equal to PQ divided by what is the radius we have? R over here. So which is equal to d theta. So this is how exactly we are supposed to get angular displacement over here. Okay. Now your job is to get one more phenomena, that is angular velocity over here. So what comes to your mind when I say velocity? Velocity is nothing but change in displacement or rate of displacement, correct? Or a change in displacement with respect to time. Now that we have discussed in a linear velocity, that is v. Now since your object is in circular motion somewhat like this, the circular motion somewhat like this, don't you think this is angular velocity? Correct? So since it is angular velocity, the representation of angular velocity gives omega, not a w, it is a omega, like omega. How to read this? Omega. So now omega which is equal to what we can have over here? Omega which is equal to, which is nothing but linear velocity we have, displacement with respect to time, and what about here? Angular velocity is equal to angular displacement with respect to time. So what is the angular displacement we denoted? There is a d theta. So now we can have a d theta divided by dt. So this is how exactly we are supposed to get omega is equal to d theta divided by dt. Okay? So this is how exactly we are supposed to do. And and if I want to get a relation between a linear velocity as well as angular velocity, what we can have over here? Linear velocity we know. Let us consider one circle over here. Okay. Now let us take one point O, which is the center of the O over here. Now for time being, one point P which is located with the distance of r vector, let us say position vector. So now if this P is moved with some displacement, let us say Q over here. Okay. So now this Q we got with the time of t plus dt. So altogether we can have this is nothing but r plus delta r. Okay. So now which means this is a direction and this is a direction and this is a position vector. Okay. So what we can have here is that, so don't you think this point P, the object was there in a point P which has moved with some displacement with respect to time, that is a t plus dt, that is up to q over here. Now your job is to get what is since this body is in a circular motion as well as a linear motion. Linear motion in the sense angular velocity, let us say omega is angular velocity and v is this is the angular velocity and v is the linear velocity. Now we know what is the formula we have for linear velocity. Linear velocity is nothing but what is the velocity we have? What is the value? What is the formula we can have with respect to linear velocity? The linear velocity is nothing but we can have if the P is the object is moved from P to Q with the displacement as per time if I take delta L over here. What is the velocity of a linear velocity we can have? The velocity is equal to delta L divided by delta T I can have. Correct? Now, with respect to delta L, what I can have V into delta T I can have over here. That is first case. Now, at the meantime, what is the angular velocity we can have over here? What is the angular velocity? We know angular velocity which is equal to omega which is equal to d theta divided by dt. So now, if we have angular velocity which is equal to d theta divided by dt, or with respect to d theta which is equal to omega into dt. Correct? Now, what we have for d theta? What we have for d theta? D theta which is nothing but arc divided by radius. Now, what we have for arc over here, we have taken it as arc which is equal to, for time being, we'll try to get the value of d theta. D theta which is equal, let us say it is equation 1 and it is equation 2. Now, what is the value of d theta I can have based on this relation? That is the PQ divided by R over here. So PQ, what is the value of PQ? That is delta L divided by R, correct? Now you substitute this delta L in the equation 2. Substitute this star. So substitute star in equation 2. What we can have over here? That is nothing but delta L divided by R, which is equal to omega into dt. Correct? Now you rearrange this. If I rearrange, what I can have? Delta L by dt, which is equal to omega into R over here. But we know delta L by delta T, which is equal to what? That is V over here. So altogether we can have V, which is equal to omega into R. So this is the relation between angular velocity with respect to linear velocity. Fine. So this is how exactly we are supposed to get the basic relation between what? Linear, where V is the linear velocity, where omega is the angular velocity. So this is the basic definition between relation between linear velocity as well as angular velocity. So now, if you want to get the angular acceleration, what do you mean by this? Is the angular acceleration. What do you mean by angular acceleration? Angular acceleration, which is nothing but rate of angular velocity, right? So this is nothing but the rate of change of angular velocity. So this is how exactly we can have over here. How to get the rate of change of angular velocity over here? That is nothing but angular acceleration is represented by alpha. This is alpha. Okay. How to represent this? This is alpha. This is a representation of alpha, which is equal to, according to this, it is the rate of angular velocity, which means d omega divided by dt. This is how exactly we can have angular acceleration. So if you want to get the linear acceleration with respect to angular acceleration, we can go with the relation like, that is we can have dv by dt, which is equal to, we can have dv by dt, which is equal to, what we can write? V can be rewritten as what? Omega into R. So d of dt into omega into R. Since what is the varying over here? So what quantity is varying with respect to time? Don't you think this velocity can be varied? Do you think at the time of rotating somewhat like this with the fixed value, do you think the radius is going to vary? Then what factor can be varied while rotating something somewhat like this? Obviously, the angular velocity can be varied, right? So now, since R is constant over here, we can take outside. So what I can write over here is equal to R into d omega divided by dt. But we know d omega by dt can be replaced by what? That is alpha over here. So altogether, can I write this is nothing but dv divided by dt is equal to alpha into R over here. Now, can I go with the rate of velocity or rate of change of velocity or rate of change of linear velocity, which is nothing but acceleration? So that's why we can have A, which is equal to alpha into R. This is the basic relation we can have under this particular concept, that is A, which is equal to alpha into R over here. Okay, where A is acceleration, where alpha is the angular acceleration, and R, which deals with what? It is the radius, and similarly here omega, which deals with the angular velocity, where R, which deals with the 1 second radius, where V, which deals with the linear velocity, okay, and d theta, which gives angular displacement. Fine? Right. Well, dear students, we'll see the one more concept of this particular chapter, that is few concepts like a time period, what is the frequency. For example, here there is one bob as we have seen just now. For example, this bob which is there in a rest position, right? So now if I give one rotation somewhat like this, it can take n number of time, right? For example, there are some definition we need to know under this particular concept, that is the time period as well as the frequency. The time period in the sense, the time required to complete one revolution. One revolution in the sense, for example, if it is a initial position, if it completes and if it comes once again with respect to the same position, which means that gives one revolution. So which means how much time it takes to complete one revolution that call it as time period. Okay. So the indication of the time period with the letter T over here. So when T which represent what? Time period of revolution of the object. Okay. And similarly the frequency gives number of revolution can complete in 1 second. So the number of revolution can complete in 1 second means there are, for example, in 1 second could be 2 revolution or 3 revolution, somewhat like this. So the number of revolution can complete in how many seconds? 1 second. That gives what? The frequency, and indication of frequency is nu over here. That is nu. How to read this? The one more term, that is the nu which is what? What is the indication of nu over here? Frequency. The frequency of revolution. In the sense, what is the value of one revolution in terms of radian? In terms of degree, still 360 degree, right? So in terms of, for example, one revolution 360 degree. So similarly, if it is a circle over here, value starts from 0, then what about the in terms of radian? From here to here, that is a pi. So altogether, that is a 2 pi over here. So in terms of a radian, what is the total value of the circle? That is a 2 pi. What is the half of the circle? That is a pi. Correct? So this is how exactly we are supposed to remember. The time period can be equal to the time required to complete 2 pi. That gives what? Time period of oscillation or time period of revolution over here. And similarly, frequency which is what? Number of revolution can complete in 1 second. Now, we'll see the relation between time period as well as the frequency. What is the basic relation we can have between time period as well as the frequency, which means if the object completes one revolution or a new revolution in 1 second, if object completes new revolution in 1 second, then we can have the relation that is nu which is equal to 1 by t, or t which is equal to 1 by u, which is equal to t into u which is equal to 1. So this is a basic relation. We can have the relation between time period with respect to the frequency, right? So that is the one thing we can have over here. And one more thing, if you want to have a relation between angular velocity or frequency with respect to time period, we can have the relation is like what is the angular velocity we can have? What is the angular velocity? If you have the center O over here and if it is a radius, let us say r over here. Now, if it completes, so for example, if it makes an angle that is a theta or a d theta, now if I complete one revolution with the time period as t. Now, what is the formula we can have for angular velocity? We know know angular velocity is equal to, that is the d theta divided by dt, right? So this is the value of, this is the formula we have discussed, it is angular velocity. So similarly, can I go with the omega which is equal to d theta can be replaced by what? D theta, let us say d theta divided by dt, which is equal to, now if we complete one revolution, what is the displacement? We have angular displacement, that is nothing but 2 pi over here. So correct? So 2 pi divided by, if you complete one revolution, what is the time taken? The time taken to complete one revolution, that is nothing but time period over here. So this d theta can, or dt can be replaced by capital T over here, that is nothing but time period of a revolution. So, and we know 1 by t can be replaced by what? The 1 by t can be replaced by what? Nu over here. So now, which is also equal to omega, which is equal to 2 pi nu over here. Also, omega which is equal to 2 pi divided by d is also possible. So these are the basic relation between omega with respect to omega in the sense angular frequency with respect to nu is called as frequency, this is angular velocity, and similarly where capital T which deals with the time period of revolution. Now there is one numerical which is appeared on the screen or appeared on the board, which means what it says, calculate angular speed. What you are supposed to get over here? It is omega you are supposed to calculate. So omega is unknown over here, and they have given that the flywheel which is making 240 revolution per minute means 240, which means they have given a frequency over here. Frequency means 1 by t. 1 by t means revolution per second or per minute. They have given the frequency as how much? 240 revolution per minute they have given. Now your job is to convert a minute to second. How to convert this? How to convert this? Just by multiplying 240 divided by 60 we are supposed to do. Now what is the formula we have to get the omega over here? Since frequency is given, we know omega which is equal to, what is the formula we have with respect to frequency? That is nu. That is 2 pi nu, correct? So this is how exactly we are supposed to write. So omega which is equal to 2 pi into 240 divided by 60, correct? So here it is going to cancel out over here. So 0 0. So here 6 1 4, which is equal to 8 pi omega. So now what is the SI unit we can have for angular velocity over here? The angular, since this 2 pi is in a radian, your job is to write radian per second. So this is the value of angular frequency we can have under this particular concept. Fine.